Alright guys, now we're going to do some rules for assigning oxidation numbers so that you can fill in your notes that I gave you as your assignment. I'm going to go through them real quick. Hopefully I don't have to do this again since this is my second time recording this because the first time I erased it. I don't know where it went. Okay, number one, first rule, uncombined elements. That's an element that's not with any other element. It's not in a compound. So elements, let's write this in, not bonded to any other element. They have an oxidation number of 0. This seems to be the one that everybody forgets. Okay, so if you see something like aluminum just sitting there by itself, its oxidation number is 0. If you see copper just sitting there by itself, its oxidation number is 0. If you see chlorine, even though it's a diatomic, it has an oxidation number of 0. It is not in a compound. If you have bromine, it's a diatomic element, but it's still 0 as its oxidation number. Okay, rule number 2. In a compound, the sum of the charges for all the elements must equal 0. Must equal 0. Okay? So there's a couple examples here. I'll do this one. So this one's already done for you. I'm going to do it over here. Magnesium, there's 3 of them. Whoops. I'm going to write 3. Okay? 3, and it has a charge of +2. Plus the nitrogen, there's 2 of them with a charge of X. We don't know what its charge is. Okay, when you look at nitrogen on your periodic table and you look at all those oxidation numbers in the upper right hand corner, you don't know which one to pick. You have to find the one that is going to give you an equation that makes it equal to 0. So I like to write them horizontal like this. Let's just get rid of this magnesium for a second so you don't get confused. And this is the way I like to tell people to do it. You're going to take the bottom number. That's the subscript number right there. See that little red mark that I just made? That's the bottom number. Bottom times the top. Here, the top number is the oxidation number. So that's a +2. Oh, that's still green. That's where I get this +2 from. Okay? So bottom times top plus bottom, that's the 2 here, times top. That's the X. We don't know what that is. All of that has to add up to 0. Okay, that's rule number 2. So when I do this lovely math here, take out your math maker, do 6, 3 times +2 is 6, plus 2x equals 0. We've got 2x equals -6. X is going to equal -3. That's a 3. So that nitrogen has to be a -3. That's the nitrogen's oxidation number. We know magnesium is +2. You'll see that in one of the other rules. Okay, let's do this HNO3 real quick. Let me erase this guy. HNO3. N is going to be our X again because N's the one that we don't know what the oxidation number is. Okay, we have H, we have N, we have O3. So we have H, there's 1 of them. That's the bottom number. Times +1, you'll see that hydrogen's almost always a +1, plus 1 nitrogen, we don't know what its oxidation number is, so bottom times top, plus 3, and oxygen is a -2, you can get that right from your periodic table, and it's got to equal 0. So 1 plus 1x minus 6 equals 0. Okay, so if you didn't see it, that's -6 right there. And then we have 1x minus 5 equals 0, so x has to equal +5. So this, I'm going to write it bigger, HNO3. We know the H is a +1, the O is a -2, and this N is a +5. Okay, I know I'm going quick, but the beauty of videos is that you can slow me down by hitting pause. Okay, you can't do that in class. Let's erase this so you don't get confused, and let's fill in the rest of these. What number are we on? We're still on 2. Okay, the oxidation number is the number inside the parentheses. parentheses, okay? It is the charge on one atom of that element. If you have a polyatomic ion, the polyatomic ion, let's say SO4, -2, that is not the oxidation number. The oxidation numbers are for the individuals. We would have to figure out what that S is, and we'll get to that later on, okay? So that -2 is not the oxidation number. The oxidation number you have to write in. Get them from your periodic table. Table E is used to determine the oxidation number for those elements. We must almost always write the positive element first. Positive element first. And the negative element last. There is an exception. Ammonia is an exception, so let's write that down here. So you have it NH3, the H is +1, the N is -3. Okay, so that's an exception. Let's go to the next page. Okay. Rule number 3. Group 1 metals. Am I recording? Good. Group 1 metals and always have a +1 oxidation number when in a compound, and group 2 always have a +2 oxidation number in a compound. So let's look at this lithium chloride right here. Lithium is a +1 because it's a group 1 alkali metal. Chlorine is a -1. Magnesium is a +2, and chlorine is a -1. The reason that this magnesium is a +2 is because it's an alkali earth metal. It's a group 2 metal. All right, rule 4, fluorine. Fluorine is always a -1. Doesn't matter. Doesn't matter where it is. It's always going to be -1. The other halogens, the other elements that are in group 17, are also -1s, as long as they are the most electronegative element in the compound. And most of the time, they will be. Okay, so let's look at this HF. Okay, we don't have a rule for hydrogen yet. It's coming in next in the list, but fluorine we know has to be a -1. Okay, from rule number 4. And that means hydrogen has to be a +1 because they have to add to 0. Chlorine is a halogen. It's in group 17, so it's a -1. So calcium, which is a group 2 metal, is a +2. Okay, and then sodium is a group 1 metal, so that's from this rule up here, and bromine is a halogen, which makes it a -1. All right, number 5, hydrogen. Whoops, hydrogen. Hydrogen is a +1 in most compounds, okay? There are exceptions with hydrogen, so it gets a little bit funky here. It is, if hydrogen is with a group 1 or a group 2 metal, that says 2 right there, group 2 metal, in which case it is a -1 charge. Here's some examples. Hydrogen and chlorine. Hydrogen is not with a group 1 or a group 2 metal, so it's going to be a +1. Chlorine is also a halogen that we got from rule 4, right? Halogens are almost always -1s, so we have hydrogen, which is a +1 from rule 5, and chlorine is a -1 from rule 4, and so we have HCl. Now, if you look at this one, hydrogen is with a group 1 metal. Okay, there's your group 1. So when hydrogen is combined with a group 1 or group 2, in this case it's a group 1, okay, the hydrogen is a -1 charge. So that's an exception. All right, oxygen. This is a big one. Oxygen, let's get a different colored pen. Oxygen is almost always a -2, okay, in compounds. There are some exceptions for oxygen, though. So let's just do this example, and then we'll move on to some of the exceptions. Oxygen's a -2 from rule 6. Hydrogen is a +1 because hydrogen is a +1 unless it's with a group 1 or a group 2. And oxygen is not either one of those things, so it stays a +1. So you've got +1 and -2. Now, when is oxygen not going to be a -2. It's not gonna be a -2 when it's combined with fluorine. Okay. Then, so when combined with fluorine, which is more electronegative, then oxygen is a is a +2. It is not a -2, it is a +2. Okay, well, you know that fluorine is always -1. You know that from this rule up here. Where's my pen? Okay, rule 4. It's getting a little messy with me circling all these rules. If fluorine is a -1 and we obey the rule that we saw before, bottom number times top, let's figure out what oxygen is going to be. Okay, so 1, that's the subscript, times x plus 2 times -1 equals 0. Then this is 1x minus 2 equals 0. X has to be a +2. And that's why when oxygen is combined with fluorine, it is a +2. Another exception for oxygen, see, oxygen has 2 exceptions, is when oxygen is in a peroxide. We've all heard of hydrogen peroxide, maybe you've heard of sodium peroxide. When the oxygen is in a peroxide, okay, peroxide oxygen is going to be -1. And peroxides look like this. They have X with a 2, or X meaning any elements, usually a group 1 element, X2O2. So you're going to have 2 2's down here. When you see that, like in sodium peroxide or hydrogen peroxide, then oxygen is a -1 charge. And you can write those in. All right, I know this is fast, but I don't want you listening to this video for an hour. And number 7, this is the last rule that we have. We're going to do the sum of the oxidation numbers in a polyatomic ion is equal to the charge of that ion. So let's get a black pen now. The charge on that ion. And you get the charges on the ions from table E on your periodic table. So Cr2O7 has a charge of -2. That is not the charge on that oxygen. Oxygen has its own charge of -2. You got that from up here on units rule number 6. We don't know what chromium is, so let's do it. Bottom, this 2, times top plus bottom times top equals, and now it's going to equal a -2. So we got 2x minus 14 equals -2. So we've got 2x equals 12, x equals +6. So now this oxygen is a -2, but the chromium is a +6 charge. Okay, so watch those with the polyatomic ions. All right, until next time, carry on.